So students, discussion कर रहे हैं हम लोग periodic analog signals की. And under the periodic analog signals, we are talking about a simple periodic analog signal or a sine wave. Students, there are three attributes that are related to this sine wave. The three attributes are amplitude, frequency, and phase. We have already spoken about the amplitude as a key attribute of a sine wave. Today we are going to talk about the frequency as a second attribute of the sine wave. Students, before we define the frequency of a sine wave, we need to talk about a period. Now, students, period is the amount of time in seconds that is required for the sine wave to complete one cycle. In other words, you know that a periodic analog signal completes its cycle after cycle. It completes and repeats a pattern after pattern. So the amount of time that it requires for a sine wave to complete this pattern once is called its period. And it's obviously measured in seconds. Students, frequency is nothing but the number of periods that a sine wave completes in 1 second. So as you can see from the definitions of these two terms, the time period or the period and the frequency, that both of these are inversely proportional to each other. The period and the frequency are inversely proportional to each other. If you want to calculate the period of a sine wave, then the period, which is represented by t, is equal to 1 over the frequency. If you are asked to calculate the frequency of a simple periodic analog signal or a sine wave, then frequency is going to be equal to 1 divided by the period of that sine wave. Students, another important point is that the periodic signal has got a period which is represented by t and is measured in seconds, and it also has the attribute of frequency, which is represented by a small f, and has got the units of hertz or cycles per second. अब students, एक slide की जानिब चलेंगे and we'll try to understand the concept of this frequency further. Students, as you can see, there are two examples that we have got. The amplitude is drawn once again against time in the perpendicular axis. Now, as you can see, in the first figure or the first example, we have got 12 periods in 1 second. So this sine wave is completing 12 periods in 1 second. Therefore, the frequency is 12, and we have got the unit as hertz, which is nothing but the cycles it's completing per second. This particular bit represents one cycle. And if you count all of these, cycle number 2, cycle number 3, and so on, this whole thing comes out to be a total of 12 cycles which are completed in 1 second, and therefore the frequency is 12 hertz. Now we know that the time period or the period is equal to 1 over frequency, and therefore in this particular case it's going to be 1 by 12 seconds. Students, in the second example, we have got 6 periods which are completed in 1 second. Therefore, our frequency is 6 hertz and our period is 1 over 6 seconds. And as you can see, in this particular case, we have got 1 cycle, 2 cycles, 3 cycles, 4, 5, and 6 cycles that are completed in 1 second. Students, in the next figure, as you can see, there are units of period and frequency that we have compared. So the unit of seconds, the equivalent is 1 second, of course, and the unitary value from a frequency perspective is hertz, and it's represented by 1 hertz. The smaller units are milliseconds, which is 10 raised to the power minus 3 seconds. Then you've got kilohertz, which is 10 raised to the power 3 hertz. Microseconds, megahertz, nanoseconds, gigahertz, and then you've got picoseconds corresponding to the the unitary value of frequency, which is terahertz.